Hello everyone, my name is Stanley. I'm a geologist, expert in mineral exploration and remote sensing. So today I would like to show you how to use softwares to identify the potential area for the geothermal exploration, and my case study will be Badakuli in Tanzania. So I'm going to use three softwares: ArcGIS, MV, and PCI Geomatica to make my work complete. So I'm going to open the first software, which is ArcGIS, and I'm going to use Landsat 8. It has 11 bands, which is very important for the geothermal exploration, especially band number 10, which has thermal sensor. So I'm going to add my bands. So I'm going to add band number 10, as you can see, and then band number 4 and band number 5, and also this one metadata, which is very important, as you can see. Then it is already here. So first of all, you have to understand that here now we have just to calculate the surface temperature, as you know. So there is a series of procedures, process and formulas that will help us just to get the surface temperature, as you can see. So I will go here to window and then search, as you can see here, and then I will write here raster calculator, and then I will search. So I'm going to choose this one for my work. So in order to get the surface temperature from the Landsat 8, there is several bands which is very important for your work. There is band number 10. This one it has a thermal infrared sensor, which can measure the accurate surface temperature. And also we are going to use band number 4 and band number 5. This is for identifying the normalized difference vegetation index. So this also is very important for our work. So this is our metadata, as you can see. So if I open, it contains a lot of information about your satellite, as you can see here. This is Radiance index numbers, as you can see. This is very important, so we are going to use this one for band number 10, as you can see again. So we have also this for band number 10, as you can see. So all of this information, it is very important for your work. So I will show you one by one. This is calibrating constant, this K1 and K2. So as I have said that in order to get the land surface temperature, there is 3 important steps you have to understand. So the first step is just a conversion to the top of the atmospheric radiance, and then step number 2 is conversion to the top of atmospheric brightness temperature, and step number 3 is conversion of the brightness temperature to the land surface temperature. So by starting, step number 1 is conversion to the top of atmospheric radiance. It is given by the formula of the band of the specific multiplicative rescaling factor. This is from metadata, times quantized and calibrated standard product of the pixel value plus this band reflectance. So most of the information will get it from your metadata if you open. So as you can see, this is band reflectance, your band reflectance, and if you go here, this one, it is band of the specific multiplicative rescaling factor. So you have to use this data. So you go to your raster calculator by writing 0.0033342 times. So this times band of the specific multiplicative rescaling factor. This one, it is band number 10. so plus 0.1, which is band reflectance, and here this will be this it will be top of the atmosphere, of band number 10, and then I'll click OK. So step number 2 will be conversion to the top of the atmospheric brightness temperature, and this we can get by taking K2 divided by ln of K1 divided by the top of atmosphere spectral radiance plus 1 minus ln of K. So K1 and K2, those are calibrations constant. This it is from your metadata. If you open here, so at the end here you will get K1 and K2 of band number 10, this value and this value. So you have to copy it, take it to your formula. So brightness temperature will be equal to K will be equal to K2, which is 1321 0789 divide by ln. So I have to find what there is ln, divide by ln of K1, which is 774.8853. This one divide by spectral radiance, this one, and then plus 1, then minus 273.15. So here you have to close the bracket again, and also here you have to close the bracket. So this one will be brightness temperature, brightness of the band number 10. So and then you have to route, and then the next step, you have to calculate the NDVI. NDVI means normalize the difference vegetation index. So this you will get by calculating or by taking the ratio of band number 5 minus band number 4 divided by band number 5 plus band number 4. So here you will go to your calculator again, raster calculator, and then you will write float. So band number 5 minus band number 4, this one divide by float band number 5 plus band number 4. So this one, so this one will be NDVI 10. So you allow it, and then after calculating it, so you have to wait for a moment. And then the next step, you have to calculate a PV data, and then PV data it is taken from the NDVI relation by taking NDVI minus NDVI minimum divided by NDVI maximum plus NDVI minus NDVI minimum square. So this one, it is a maximum, NDVI maximum, and this one it will be NDVI minimum. So you go to your raster calculator, and then you will write square. So you will find the square of NDVI minus NDVI minimum, means minus will be equal plus, plus 1 divided by NDVI maximum, means you close the bracket, NDVI maximum, which is 1, minus NDVI minimum, means 1 plus 1, right? 1 plus 1 here, and then you have to close the bracket here, and then you close the general bracket here, and you have to close here. So this will be PV data, PV of bar number 10, and then you calculate. And the next step is you have to calculate the emissivity of the rays, and this will get by taking the constant of 0.004 times your PV value plus 0.986, as you can see. So you have to go to your calculator again. So you have to wait for the PV data here. It is still we don't have, so you have to wait for a moment. So it is already, I think it is okay. So you go to your raster calculator, and then you have your PV value. So to get the emissivity, you take 0.004 times your PV value, this one, and then plus 0.986, 0.986. So this will be your emissivity data. So this will be E10, and then okay. So then after you have to calculate now for the land surface temperature. So everything it is okay now. So you have to wait for the emissivity data because it is important. So in order to get the surface temperature, you have to take the bracket temperature divided by constant 1 plus this wavelength of the sun rays, and then times this brightness temperature divided by the C2 bracket times the ln of emissivity. So you have to go to your calculator here, raster calculator. So press it here. You have to go to your raster calculator, and then you take brightness temperature, this one, brightness temperature divided by bracket 1 plus divided by 1 plus bracket this wavelength of the band number 10. It is the wavelength of band number 10, it is constant, it is 10.8. you have to understand this, 10.8 times, and then brightness temperature again divided by C2. This is constant, but it is value, it is 388, yeah, 4388. Then a bracket times ln of E. So we have to find where there is ln here, ln of E of emissivity. So this one E, and then so ln of emissivity. So you have to close the bracket here. So this one 2 3. So here will be 1 2, and then 3. This is 1 2 3. Okay, so this is going to be land surface temperature of band number 10. And then you have to allow it to process. So it is over now by calculating the land surface temperature. So you can hide all of this and to remain with our final product, which is land surface temperature from the Radiance 8 as you can see here. So you have to add all these bands. Yeah, it is okay. So you have to wait for a moment. So you have to do all these things after making sure that your satellite image, it is already, it has no any error, maybe noise errors and other errors. So you have to make sure that you correct all the errors before anything, and then after you have to go to the PCI Geomatica to extract it for the lineaments. You know, the formation of the geothermal resource, it need the permeable rocks that will allow the fluid to penetrate, and also the hot rock, or maybe near that will go near to the magma chamber or the hottest rock. We have to understand this. So fault is very important for the geothermal exploration. So this is, as you can see, the highest temperature here, it is 51 this one, and the lowest temperature this one. So this area will be more favorable for the exploration of the geothermal. So you have to change the color here, you have to make the visible color. So you have to change to choose the best color here, and then you have to invert here, and then this one you can cancel. As you can see here, this is my satellite image. As you can see, where there is a red means that the temperature is high. So this zone is very important, or is good for the geothermal exploration, as you can see. So then after extracting the lineaments from the PCI Geomatica, you can add it in your. So as you can see, those are my lineaments and faults. So you can add the size here for visualization. So maybe 2 3, maybe I can put it black, maybe 2 3, maybe visible, as you can see here. So this is our lineaments, as you can see. So it's very important for the formation of the geothermal. So if you want to understand maybe the temperature of this zone, you have to click here, and then you get there is 43 degrees Celsius, you can see here. So then after you can make the analysis, and you can have the plan here just to conduct now for ground truthing for your exploration of the geothermal. So now you have faulty, which is area for the penetration of your fluids. Again, you have the area of the zone with the highest temperature. So this zone, it has the lowest temperature, as you can see here. So thank you for watching. Again, my name is Stanley. Your register for anything, you can check me through 0752 260138. This is my WhatsApp number, or for a normal